Stargazers may have just discovered a new type of phenomenon in the Orion cloud, a well-known celestial nursery. But what if I told you that the James Webb Space Telescope recently found something in space that shouldn't exist? And not just one or two, but multiple structures like that. 6 enormous systems have recently been identified by NASA using data from the James Webb Space Telescope. And researchers are confused because they might have to rethink everything they thought they knew about the universe. Let's dive into these incredible findings. Massive ancient galaxies in an unexpected background. The James Webb Space Telescope discovered 6 brilliant red spots of light in what seemed like a regular cosmic background. These aren't ordinary spots. These are some of the earliest and largest galaxies ever observed, dating back up to 13.3 billion years. These 6 galaxies were so red that they likely formed just a few 100 million years after the Big Bang. This discovery challenges what scientists once believed about galaxy formation, as they previously thought it took much longer for the first stars and galaxies to form. Yet, these ancient galaxies were already enormous and teeming with star formation just a few 100 million years after the Big Bang. One of these galaxies is 1 trillion times more massive than our Sun and 100 times the size of the Milky Way. This revelation has shaken up the cosmology community, suggesting that the universe may not have been as dark and empty as previously thought in its early stages. New discoveries in exoplanet atmospheres. For years, astronomers have been fixated on finding exoplanets, and one of the most promising candidates is K2-18b. Why is it so significant? Well, the James Webb Space Telescope recently detected water vapor in its atmosphere. But that's not all. Carbon-bearing molecules like methane and carbon dioxide were also found. What makes K2-18b even more exciting is the detection of a compound called dimethyl sulfide, which on Earth is produced by living organisms. Could this exoplanet have the right conditions for life? The discovery raises some intriguing possibilities. Origins of the cosmic web. Using data from the James Webb Space Telescope, astronomers discovered a string of 10 galaxies arranged in a line, dating back only 830 million years after the Big Bang. This is akin to finding a childhood photo of our universe. But why is this so significant? Because these structures shouldn't have existed at that time according to our current understanding of the cosmos. The string of galaxies is about 3 million light-years long, anchored by a very bright quasar, an active galaxy with a supermassive black hole at its center. This line of galaxies could eventually form into a massive galaxy cluster, similar to the ones found in our part of the universe. Enormous black holes in the early universe. It's well known that black holes grow by consuming stars and gas, but the James Webb Space Telescope has captured images of extraordinarily massive black holes hiding in the early universe. One such black hole is located in a galaxy known as Y the Great Part Y, about 13.2 billion light-years away, which means we're observing it as it existed just 470 million years after the Big Bang. This black hole has a mass between 10 million and 100 million times that of our Sun, which is staggering, especially when considering that it might have accumulated this mass in a relatively short period of time. The Horsehead Nebula. The Horsehead Nebula, also known as Barnard 33, is located about 1,300 light-years from Earth. Thanks to the James Webb Space Telescope, astronomers have been able to observe the intricate details of the illuminated edge of the nebula for the first time. This nebula formed from a collapsing interstellar cloud and glows due to nearby hot stars lighting it up. The gas cloud around the Horsehead Nebula has mostly dispersed, but the iconic horsehead shape is still intact, made of denser material. The nebula is expected to last for about 5 million more years before it begins to dissipate. Astronomers can now track how dust particles are being cleared away by ultraviolet light, creating complex patterns in the process. Supernova remnants. In the Copia constellation, about 11,000 light-years away, lies the aftermath of a star explosion that occurred about 3,140 years ago. The James Webb Space Telescope has provided a clearer view of the warm dust left behind, which plays a crucial role in forming planets and life. This dust, composed of heavy elements like sulfur, oxygen, argon, and neon, glows in beautiful shades of orange and light pink. The telescope also captured light repeats, where the original light from the supernova is absorbed and re-emitted as infrared light by the surrounding space debris. The Snake Nebula, about 1,300 light-years from Earth. The Snake Nebula covers a vast area of 16 trillion miles by 11 trillion miles and is where many young stars are being born. The James Webb Space Telescope has revealed many surprising features in this nebula, including aligned protostellar outflows, jets of gas ejected by newborn stars. These jets all point in the same direction, a phenomenon never seen before. The telescope also captured an image of a planet-forming disk, which looks like it's fluttering in space, an awe-inspiring discovery. Secrets of the galactic core. The James Webb Space Telescope has also provided the most detailed image yet of the Sagittarius A* region, located about 300 light-years from the Milky Way's supermassive black hole. This image reveals about 500,000 stars, but also some strange needle-like structures in ionized hydrogen that defy known cosmic patterns. These structures are much larger than previously thought, and astronomers are still puzzled by their origin. Additionally, the telescope captured images of a group of protostars, stars still in the process of forming and accumulating mass. Gigantic cosmic discoveries. If you're passionate about space, you've likely heard of some of these monumental discoveries, and there's so much more to come. The James Webb Space Telescope is pushing the boundaries of what we know about the universe, unveiling its secrets in ways we could only dream of just a few years ago. From ancient galaxies to new planet atmospheres, the telescope continues to reveal a universe far more complex and surprising than we ever imagined. These groundbreaking discoveries are reshaping our understanding of the universe, and we're just beginning to scratch the surface. What other mysteries will the James Webb Space Telescope unlock in the coming years? Only time will tell. The James Webb Space Telescope has provided remarkable insights into numerous astronomical phenomena, shedding light on the early universe and the complex processes shaping galaxies, stars, and planetary systems. Here are some of the most significant discoveries. Cosmic fibers and the aftermath of supernovae. The infrared capabilities of the Webb telescope have allowed astronomers to study the fibers created in the wake of cosmic explosions with extraordinary detail. This has provided valuable insights into the processes that occur after supernova events, particularly the role of these fibers in the evolution of the universe. Early universe galaxies. One of the most groundbreaking findings of the James Webb Space Telescope is the discovery of galaxies formed less than 1 billion years after the Big Bang. These distant galaxies are extremely faint and difficult to observe due to their vast distances and the darkening effects of cosmic expansion. However, Webb's advanced optics and sensitivity have enabled scientists to study these ancient galaxies, offering new knowledge about their formation, star formation rates, and the presence of essential elements like gas and dust. Distribution of dark matter. Although dark matter remains one of the greatest mysteries in astronomy, Webb has significantly contributed to understanding its distribution within galaxies. By studying the gravitational effects of dark matter on the movement of stars and gas, astronomers can create detailed models of its presence and role in galaxy formation and structure. Cosmic winds. The James Webb Space Telescope has provided new insights into cosmic winds, streams of charged particles ejected from galaxies. These winds are driven by the energy produced during star formation and by the activity of supermassive black holes at the centers of galaxies. Webb's infrared observations have helped trace the origins and paths of these cosmic winds, revealing their impact on galaxy evolution and star formation. Interstellar organic molecules. Webb has also made significant strides in detecting complex organic molecules within our galaxy. These molecules are crucial for the formation of stars and planets and are considered building blocks for life. Through high-resolution spectroscopy, Webb has identified molecules like methanol and complex hydrocarbons in interstellar clouds, providing insights into the conditions under which stars and planetary systems form. Gravitational lensing. A key phenomenon predicted by Einstein's theory of general relativity. Gravitational lensing occurs when the gravitational field of a massive object distorts and amplifies the light from objects behind it. The Webb telescope has observed this effect, allowing astronomers to study distant galaxies and galaxy clusters that would otherwise be too faint to detect. These observations offer important data about the distribution of dark matter within galaxy clusters and the properties of the lensing objects themselves. Extragalactic background light. Webb has contributed to our understanding of extragalactic background light, the faint glow of light that permeates the universe, originating from all sources of light throughout cosmic history. By observing distant galaxies and quasars across various wavelengths, Webb has measured the intensity and spectrum of this background light, providing insights into the cumulative emissions of stars, galaxies, and black holes over billions of years. These observations help refine models of galaxy formation and the overall history of the universe's glowing evolution. Nebula dynamics. The James Webb Space Telescope has also revealed the intricate dynamics of nebulae, vast clouds of gas and dust where stars are born. Using infrared observations, Webb has allowed astronomers to study how gas moves within nebulae, how it falls together to form new stars, and how it is shaped by radiation from young stars. These findings offer crucial insights into the processes that govern star formation and the life cycles of interstellar material. These discoveries illustrate the powerful role the James Webb Space Telescope plays in advancing our understanding of the universe. From the earliest galaxies to the complex workings of nebulae and dark matter, each observation adds a new layer to our understanding of cosmic evolution, challenging existing theories and inspiring new questions about the nature of the cosmos. As Webb continues to explore the universe, astronomers eagerly await further revelations that will shape our understanding for generations to come. James Webb has made some truly groundbreaking discoveries in space, revealing new phenomena that challenge everything we thought we knew about the universe. One of the most exciting revelations is the discovery of Jupiter-mass parallel objects, large, free-floating, planet-like bodies that exist without being bound to any star. These objects, dubbed jumbos, were found in the Orion Cloud, about 1,350 light-years away from Earth. Unlike anything we've seen before, each of these jumbos consists of two sections, forming a binary-like planet system. Their masses range from 0.6 to multiple times that of Jupiter. What's astonishing is that they remain stable as dual systems, defying expectations since such objects shouldn't typically form or remain together in this way. Another intriguing find involves radio waves emitted from one of these jumbo systems, specifically from the large object called Large 24. Using the KLJ-Jansky Very Large Array, astronomers detected consistent radio transmissions coming from both parts of the binary. This unexpected behavior leaves scientists in awe because these objects shouldn't theoretically be able to form or hold together as binary systems. James Webb has also transformed our understanding of star formation. Normally, the dense clouds of gas and dust in which stars form block most visible light, making it difficult for us to observe the process. However, Webb's infrared capabilities allow us to peer through these clouds, revealing phenomena that were previously hidden. For example, in the Kolomayuki complex, located just 390 light-years from Earth, the telescope captured a stunning image of around 50 young stars. Many of these stars are of similar mass to our Sun. Thanks to Webb, we can now see the high-energy bursts of gas and particles being released by these stars, which illuminate surrounding clouds of hydrogen. Without this technology, we'd be left with nothing but a dark, blurred image. James Webb has also provided breathtaking insights into the Ring Nebula, M57, located 2,500 light-years away. Known as one of the most visually stunning planetary nebulae, it was already well known for its beauty. However, Webb has uncovered intricate details that were previously unseen. The inner part of the ring consists of very hot gas, while the outer shell contains carbon-based molecules called polycyclic aromatic hydrocarbons. One of the most surprising findings was the discovery of 10 concentric shockwave rings surrounding the nebula, formed by the explosion that created the cloud. These rings are organized in the shape of a shot, a feature never before observed in such detail. Another fascinating discovery by Webb relates to galactic collisions. It's well established that galaxies merge over time, but Webb's images have provided unprecedented insight into these cosmic events. Specifically, Webb captured images of two galaxies colliding, known as ARP-299, located about 150 million light-years from Earth. The collision is triggering bursts of star formation, stirring up gas and dust within these galaxies, and potentially fueling supermassive black holes at their centers. This collision provides critical clues to understanding galaxy evolution and the growth of supermassive black holes throughout cosmic history. Lastly, James Webb has revealed a detailed view of the Cloak Cloud, a massive remnant of a star explosion. Located around 2,100 light-years away in the constellation Cygnus, the Cloak Cloud is the leftover debris from a massive star that exploded centuries ago. The resulting explosion launched material into space, creating intricate filamentary structures that can now be seen in stunning detail thanks to Webb's capabilities. These discoveries, all enabled by the James Webb Space Telescope, are expanding our understanding of the universe in ways we never imagined possible, and we're only just scratching the surface of its potential.